Hello friends, welcome back to the videos. As usual, I am Amoga Bantrikalli. So this is the second paper on deep learning, which is going to make you understand more clearly what are all the things you need to just speak of before jumping into an machine learning. So the paper name is Deep Residual Learning for Image Recognition. This is your paper, which is freely available. You can download from the below link which have been given in the description. So the very first one, deeper neural networks are more difficult to train. So by making use of this residual learning framework, it becomes easy for training. So what is residual networks? So without having any kinds of restrictions, we are going to bypass some of the layers. So that is called as a residual learning. So in this paper, we are going to see that we are going to skip some of the unreferenced functions, and it has been applied on a layers called as on a database called as an CIFAR10 with 100 and 1000 layers. So we can jump into this paper. Let's understand what is this residual functions. So this is your residual block. So this is a weighted layer. So this is another weighted layer, and this is an output or another output function. So this is X stands for an input and Y stands for an output vectors. So here you can just observe here function of X. So in between each weighted layers, we are having a ReLU activation function. So the ReLU is the one which is going to provide you the values in the range of 0 and 1. So here you can just see we are going to skip this weighted layer because it is unreferenced function. We are skipping it and we are just going to a nest activation function Vx plus X. So this is an bitwise addition. So here we are going to have an identity matrix. Skipping identity here means a representation of data. Neighborhood representation data should be of having an identity. So which are all the data set is having identity? So those data sets will be combined, not having any unreferenced functions, then those will be skipped. So by doing this, the training time will be reduced. So this is what the difficulty is going to be just reduced like this. Just make a note here. So this is fx plus x. So this is a function of input, and we are just going to have a bitwise addition of our inputs by just replacing this weighted layer. So this is what it has been represented here. The formulation of fx plus x can be realized by feed forward neural networks by making use of a shortcut connections. So in order to make a shortcut connections, we need to understand what is shortcut actually means. So shortcut actually means that skipping one or more layers based on the identity mapping. So here identity shortcut connection is not going to add any of the networks, or it is not going to add any of the extra parameters. So entire thing it is going to follow an one method called as an backpropagation with SGD. Backpropagation is a technology or algorithm which is going to update all the loss matrix of each layers will be updated at once. So that is called a backpropagation. To understand in deeper what is shortcut connection. So here, without having any of a conditions, we are going to make use of an identity. So that is what it is going to tell you. So it is parameter free, and we are going to pass all the information from one layer to another layer by bypassing any of the unrelated function in between them. So that is called as a shortcut connection. This one is how we are going to identify this mapping of shortcuts. So this is your respective equation. So X stands for an input, Y stands for an output. So this is a function of an input what we have seen in a last figure, and this is a weight of a respective layer or a weight layer. So this is what it has been explained here. Tell that f plus x, x is an input, f is a function. So in order to skip any of the weighted layer, we are going to perform an element-wise addition. This is what residual layer which have been used for various databases. So this one is a VGG19. We are going to have a 3x3 convolution for an 64 layers. So 3x3 convolution is a one which is going to reduce the size of an input image. So you can just see here the output size is 224. So the pooling, is the one which is going to get the maximum. Example, here we are going to make a pooling on 3x3 matrix. Inside a 3x3 matrix, which matrix is going to have a maximum number that is going to be accessed. So that number is going to represent the whole 3x3 matrix. We are going to discard all the 3x3 values. So that is 3x3 is 9. So one value is taken from that value is maximum of this 3x3 matrix. So that is 9 elements. So this one element is going to represent the rest 8 elements. So that is called as a pooling. You can just observe here from 224 it has been reduced to 212. So in this manner, so this is the thing which is going to happen in a normal networks. We are having a maximum pooling and we have been just reduced it, and we are going to have a classification version. So this is the normal working. So here comes a residual layers. So soon after the image have been applied, we are having a convolution for 7x matrix. So again a pooling comes. So here we are going to residual the layer based on the identity. So all the weights of this x input has been added with the function of an input. So we are just bypassing these two layers which are unrelated to the respective image category. So you can just see here, by just bypassing all these layers, we can just considerably reduce the complexity in a training. So this is all about the residual image layers in a neural networks. So you can just see how this thing have been implemented in this paper. So they have been taken an image net which have been just made us. So the image have been resized and it has been cropped to an 224 cross 224. So sampled images. First one, they have been just cropped image with a size 224 cross 224, and they have been used a standard color augmentation, and they have been used the normalization. Why we need normalization of the data is to confine the data, removing the unwanted materials from the data set or from an image. So later they have been used a batch size of 256. So the batch size is like so they are going to make some sorts of an iterations on a batch for 256. So the learning rate is 0.1 and the error rate which they have been just trained for, it is 60 into 10 raised to 4 iterations. So for each image, so 60 into 10 raised to 4 iteration times it has been just going into a layer in order to just finish one training. So this is all about something like a training facilities they have been done in this paper. So the next one is weight decay or a wait time, and they didn't use any of the dropouts here. Dropout which have been learned in an previous deep paper 1. You can just find that video in this respective link. So this is coming out of testing phase. In a testing phase they have been taken a 10 crop testing in order to test whether the network is working fine or not. Results, they have been used a fully convolution form of a network that is 14.2 and an average scores with the multiple sizes of their scores, and they have been just given which are all the resides thinking or resides images. So this is all about implementation which they have been carried out, and you can just see what is the implementation results which they have been just obtained for. So they have been used a Cipher 10 as a database. They have been taken a 50,000 data training images and 10,000 testing images, and they have been having a 10 classes, mean to say 10 different decision making things. So this is the result which they have been obtained, and they have been just given in a form of a lens or a graphs. You can just make an easy understanding without a residual and with residual layers how the network have been performed very well. So this is another paper which you can just dive with before going to machine learning. Thanks for watching. Give thumbs up for this video if you really like this. If you find this video is helpful for your friends, do share them. This channel provides information about machine learning, deep learning, C languages, and an ARM Cortex or an ARM microcontroller programming both in C and assembly. Thank you for watching. Give thumbs up.